All right, in this video, we're going to talk about upper and lower sums. So when we look at these, we are going to break it into 4 subintervals, just like before. So there's our partition of 4. And so if we go from here to here, we now have our 4 subintervals. So what you do is you look at each partition individually, and you can see that our function goes from here to here. So at 2, x equals 0, we get 2. That would be our minimum. So you're just looking at each subinterval and picking the lowest value in that subinterval. So when you draw that line, the only point that should be touching is wherever you started that rectangle. So like here, should not be crossing your function because it is the lower. Just like that. All right, so those are our lowers. So to find that area, what we're going to be using is our calculator. So again, we're going to do width times our heights. We'll go to here. And so our width here is 1. And our heights for the first one you can see is 2, but we're not going to approximate these. We need the exact value. So what we're going to do is take our calculator, plug in the function. You're going to put in 0 and 4 and then hit zoom 0 in your calculator. And then adjust it with 0 and you'll get this graph like this, but you just need the graph itself from 0 to 4. And we're going to plug it in. So the first one is at 0, and so we need f of 0. The next one is at 1. You can see that's where our dot was. So we're just plugging in the x values that give us these dots. So the next would be f of 1, f of 3, and f of 4. So we use our calculator to find those values. So all you have to do now is go trace and 0. And yes, you can use the table function if you want, but I like to have the picture. So our first height was 2, which makes sense because it was 0. And then we're going to plug in 1. So trace 1, and that's 2.841 to 3 decimal places. And then now f of 3. So trace and 3, and that's our next height, which is 2.141. And then f of 4. So trace 4, 1.243. Double check that one. Yes, 1.243. And then now we're just going to plug all these in the calculator. And that gives us 8.225. So that is our approximation. It's not a good one. It's an underestimate, but it is an approximation. So now we'll do it the same way, but with upper. So let's cut it into 4 parts. So 1, 2, 3 lines. And again, we're going to be picking from these endpoints and all the points in between. And so we're going to pick that one right there. So our first point is going to be at f of 1. So our area here will be a width of 1. That's our width. And then our heights, we're going to use f of 1, which we already know. And then the next one. So right there, you can see it's actually at a maximum value. And we already know this is a sine function. So if we were to take the derivative of that and set it equal to 0, it would just be our sine function's max, which is at pi over 2. Just like the graph. And so that would be a height of 3, just there. But we're going to just plug in f of pi over 2. And then the next one would be here. I almost picked the lower. And so what is the x value that gives that? That would be 2. And then the last one is here. So we go across and down. I'll go this way. You make sure you always fill these in because we are showing an area. So there we go. And then the last one was at 3. All right, so some of these we've already found. So f of 1 we know is 2.841. And I said I would show you in the calculator how to find this. So let's just look at our graph here. So all you have to do is if you know the trig function and you know it's at pi over 2, you could just plug in pi over 2. And then it does say it's 3. But if you don't, in your calculator, if you go to calc, you'll see that you have a maximum value in there. So you select 4. And we know our interval is from 0 to 4. But we also know it's between 1 and 2. So we're going to go left bound of 1, right bound of 2. And you can see it draws our little subinterval. And then now we just hit enter for our guess because it doesn't matter. And there it is. There's our pi over 2. And there's our max of 3 that we wanted. So it's at 3 right there. So that's 3. And then f of 2 we haven't found, so we got to plug that one in. So trace 2, 2.909. Oops, 909. I was thinking of the 3 for the next one. So f of 3 we already know is 2.141. So now all we have to do is plug these in our calculator. Slide it over a bit to make room for the calculator. And we get 10.883. And so that is an overestimate because we use maximums. So maximums gave us an over. That gave us an under. And so you could honestly take the average of the two to find a better approximation. Take your under, take your over, and average them. But there is a way to do it in your calculator as well. So those functions we had before, if you hit second calc, you'll see that number 7 is an integral. So that is our area that we were doing right here, our integral function right here. We're going to learn that that gives us the area under the curve. So if I click number 7, it's going to ask me for my lower limit. And again, we're going from 0, hit enter, all the way to 4, and hit enter. And what it'll do is fill it in for you and then give you the exact area. And we're expecting something in between 8 and 10. And it says it's 9.65. So that is the actual area, which makes sense. So we know that we did this correctly, hopefully, and everything is good. So that's your lower and upper.